like to thank the stakeholders for coming first off. My name is Greg Finkelberg.
After a few minutes.
Diana Cameron. And I'm Rachel Snyder, so thank you guys.
Really quick, I just wanted to start off with our problem definition, which is the rapid growth of the City of Goodyear has led to an increased demand for fresh water. And the contaminated groundwater has made the implementation of reverse osmosis treatment methods necessary, but has led to high operating expenses in the creation of large amounts of wastewater known as brine. It's estimated that about 500,000 gallons of brine is created per day using these methods, and about 15% of the treated groundwater is lost to wastewater. So the stakeholders we really want to focus on during our research were the citizens of Goodyear, the local government, developers, and environmentalists. We felt that was very important to get to understand multiple perspectives of this issue in order to get a more broad view of the subject and understand the individual needs and concerns of each stakeholder. Our project objectives were to obviously find environmentally conscious ways of disposing of the brine, but we also wanted to focus on coming up with more efficient treatment methods as well. These are some of the questions we used to kind of guide our research. We not only wanted to find the best solution from an environmental standpoint, but from also political, technological, and economic standpoints as well. We wanted to make sure our methods of treatment and disposal were energy efficient. We understand that financial resources might be scarce, so we wanted to make sure that our methods were more practical to the given resources of the city. And finally, we want to make sure that we're researching successful methods being implemented in Arizona and in places having similar problems to Arizona as well.
So kind of how we broke up our project is each of us focused on one of the disciplines of sustainability. So somebody focused on environmental solutions, more political solutions, more economic solutions, and then finally just some of the new technologies that have been implemented to maybe look forward to in future years. So we just picked 4 that we thought would be most applicable to you guys as stakeholders. So the first we talked about is sewage treatment, which is what you're doing right now. And we kind of considered the possibility, because we do know that it's a pressing issue, that you need to figure out a way, because your sewage treatment plant is almost at capacity right now, so you need to figure out a way pretty soon of how to deal with this increasing amount of brine. So we were like, well, what if they did a new sewage treatment plant? So a pro, obviously, is it's the status quo. You guys already know how it's functioning. However, it is pretty costly. I think we looked, there was just a new sewage treatment plant built in Las Vegas, and it was around $300 million to build, so that's pretty costly. In addition, you're losing a lot of the water through the brine waste, about 15% actually. And in a state like Arizona, where water is so important, and we don't want to see necessarily all of that water going to waste when it could possibly be being used. Another problem with sewage treatment is it degrades the quality of your other effluent. So when you put the brine water to that plant, you're losing potential benefits of effluent reuse programs, especially if that was something you're looking to do in the future. So the next thing that we were looking at were evaporation ponds, which the other group touched on. And we also had the opportunity to go to your plant, and we noticed all of the space around it. So we thought that this could be a potential really great solution, because you do need a large amount of space. You already have that pit, so it's definitely pretty plausible. There's precedence for it as well, and the city of Chandler currently is using evaporation ponds and in addition to a treatment facility. So it definitely is possible, and then that allows you to have higher quality effluent. But however, there are cons to evaporation ponds. We know that you guys are a growing city, so from a developer perspective, they might want to use that land, and there might be some balance of interest, things to take into consideration. In addition, it is more of a short-term problem, because evaporation ponds work best with lower quantities of brine. So as you grow and as you're producing more of this brine, it might not be a long-term solution. And finally, there have been problems in the past with lining and contamination, and we don't want to be contaminating the groundwater that you're using for all of your water. Also there is a lower filtration rate compared to the reverse osmosis process. No, that's okay. So another method that we looked at were solar ponds. And this is similar to evaporation ponds, but the main benefit of a solar pond is it provides energy to power the facility. So if you use a solar pond, you would still be sending some of the brine water into the ponds, but this would help in powering the reclamation facility. And we've seen a successful model implemented in Texas. So some of the pros are the climate is very similar to here. We already know that it could be effective. However, there are pretty high costs to initially install them, although you would see the benefit over time. You can hit the next one because it goes to pros, I think. And also you need a constant source of water. So it's something that if you decided to invest in that, you would need to be continually sending the brine water to it. And then the final thing we looked at was phytoremediation, which the other group also touched on as well. Obviously the pros, it's a very socially beneficial and environmentally beneficial solution. You can have kind of regrowth of the Gila River, and we think that that's really awesome. But however, there just hasn't been enough research done on it to really make it a valuable or really feasible solution for the short term and pressing nature of the problem.
Okay, so I talked about the results and findings. So basically, after all our research, our results and findings have shown us that there really is no one clear solution to this problem. Being a wicked problem, it has unintended consequences. For example, the solutions that have been currently being implemented have the unintended consequences as the issue of toxic waste. What we tried to do, it was challenging for us to try and overlap through each different perspective, which we just dissected the problem to find one clear solution. Although we couldn't find one clear solution, after researching each sector, the technologically, politically, environmentally, and economically, we came up with a couple solutions. We also understand that this is a pressing issue and that the City of Goodyear needs a solution now. The immediate solution we would suggest is the use of an evaporation pond. The benefit of an evaporation pond is that it is already being implemented in Chandler, so we know that it is feasible in Goodyear. But the main issue with that is also, as she talked about, the issue of the waste. For a more long-term strategy, we think it would be better from an economic and maybe innovative perspective to implement solar ponds, as she talked about. Although it does require a constant water supply, it in return provides energy, and the cost to operate is extremely low, after the initial costs, obviously. Also, climate is key for solar ponds, and we have the right climate here in Phoenix for them, as well as seeing it in El Paso, Texas, and it had such a high return there that we think it could be feasible for the future here. Another solution to look for into the future is also the phytoremediation, which you talked about. From an environmental perspective, that could be ideal to look into with more research. Basically, it really is important to think about the key competencies when solving any sustainability wicked problem. For us, we use systems thinking throughout our project. The way that we went about solving this problem, we split up the problem into different perspectives, looking at different angles to do individual research, and then we came together as a whole system. Once we came together as a system, we realized that there is no one solution that solves each aspect of the problem, but it helped us to see what could benefit the system as a whole in the short term as well as in the long term from each perspective, politically, economically, environmentally, and technologically.
Okay, as my group just mentioned all the different possibilities that you guys have available, we're still facing some challenges that we need to address. So some of the mainly one of them is the cost. These are substantial capital investments that need to be thought in whether the community is willing to to pay for it. Still, it's something that needs to be talked about in meetings with the city mayor. Also, some of the, it's another issue you mentioned on your problem that there's a growing population, and the trend and statistics established indicate that the projection population living in cities is on the rise. So this is one of the challenges that a lot of cities are going to be facing. So it's better to face it now and then address the issue when it comes. So another potential issue is the water scarcity. As you know, climate change has been affecting climate all around the world, and one of them being the changes in the atmosphere affecting rain and stuff. So another nice thing that's going on, there's research going on that's potential new technology that's going to be implemented. This one is going to be implemented, probably removing this old technology, making it better. And unfortunately, reverse osmosis, as you guys know, it's the best solution available right now, and that's creating a lot of, substantial amounts of brine. I want to, oops, sorry. Which one is that? Sorry. I just want to share a sustainable vision that I just came up based on this research. I noticed in your facility one of the projects going on where you guys are growing some plants, and phytoremediation is basically the utilization of plants to remove chemicals. So as you can see in the picture, we have, instead of just letting the water run through the Gila River, why don't we convert this into something more sustainable where we approach or we where we our goal will be to kind of like create an environment, an ecosystem for flora and fauna, creating a community, a recreational part for the community, and also maybe perhaps creating jobs along the way. So that was one of the, and then the best solution of this is basically that you're removing chemicals from the water naturally, using plants to remove the chemicals. It's been, based on my research, there's some plants that are really making some good removal of chemicals still. There's some ongoing research about these different plants. So, but this is one of the visions that it'll be sustainable because it touches all these different aspects that we learn in class. So it's one of the visions that I wanted to share. Now, concluding thoughts. Based on this information that we researched, I just hope that this information is helpful for you guys in whatever your decisions you guys make, whether you choose either possibility available, you guys make it sustainable, make it where you guys emphasize not just the social, the ecological, the justice, but also you guys thinking on your decisions about future generations. And basically, that's it. So, any questions you guys like to ask or to the class regarding this?
Sorry, what's a solar pond? It's not like solar over it because it won't evaporate, right? Or is it just?
Solar pond is basically a pit where we'll be basically putting all the brine into a big pit. Solar, what it means solar, the sun heats up the water, it evaporates, and just leaving, basically the end, you're going to be leaving all the residue, all the chemicals are behind. So that's basically.
Okay, I'm sorry, I thought that was the evaporation.
No, yeah, that is an evaporation.
Oh, I'm sorry.
That's okay. Greg, do you want to?
Yeah, the solar pond, it's really high in salt content, and it'll absorb the heat from the sun, and it can be converted to powering the facility.
Yeah, sorry, I got confused. That basically, it's also using solar energy. What it does basically, it's a chemical reaction. You got different levels of salt, and the one being at the bottom, I think it's the saltier. So as it heats up, all the energy that they pipe up, all the water that's underneath becomes so hot that pump it up to the facility where they use it for just like boiling water, basically to generate electricity. So that's what the deal behind this. Any other questions?
From the class? Any questions from the
In your presentation, you cited Chandler as an example for the evaporation ponds. Do you have a relationship to how much, volume per day that they send to their ponds?
Yes, not with me, but I could definitely get that information to you. I think that, in the report that we looked at, I believe that because it's both evaporation ponds and they also have a facility, so I'm not sure exactly how much it would be that is devoted. It goes to the evaporation ponds and then goes to the plant, but I believe that they generate more water waste than you do as a city, so, yeah. Don't know specific amounts, but we could definitely look at that information. Okay, yeah, I have your email.
And I have one other question. At the beginning, you cited to the different stakeholders, and your responses about choices sounded to be directed to the government and possibly to the resident as a ratepayer. Would you like to respond to what you think the environmental groups would respond to those choices as you presented?
Sorry, could you repeat
You said
that?
there were environmentalists as stakeholders in this
Yeah.
process, so I'm just saying, I didn't hear in your evaluation how you thought they would react to the comparison of these options. Could you share what you think would be?
Well,
response to
did you
that?
have any solution in particular that you wanted me
We
to?
were three, right?
Yeah.
So could you
So
tell me
the
which one you think they
solar
would-
pond, I think they would really appreciate because it generates natural energy from the sun instead of the tons of energy that the reverse osmosis facilities use. The evaporation ponds, as long as there's no leaking back into the groundwater, I think they wouldn't have a problem with it. So, as the other group said, there would have to be inspections to make sure the lining doesn't break. And did you want to touch on it better?
Sure. As I mentioned, sustainability basically it's a balance between the ecological, the social, and the environment. And like you mentioned, what would people think about this? I think they will react in a negative way because, as we brine, basically it's highly concentrated chemicals that we can just dump them into the river. So one of the options, well, the ecologicals will like I say, they'll be opposed to this type of options because of the chances of leaking into the water systems, into the rivers. So that's one of the potentials that they might be against because of that. So
So the best solution from that perspective would be?
The fire remediation, probably. Obviously, there's not
okay.
really enough research done to fully implement that, but from an environmentalist perspective, you're both filtering the water in a natural way, and you're putting it back into the Gila River, so it could be a huge regeneration type of project for that. Lots of ecosystem regeneration as well. So probably they would be most excited about that option.
Thank you.
Let's thank our group.